go over a little bit. We're going to go over a little bit more of probability from a theoretical standpoint, and then we're going to get into statistics, where we actually do with more empirical probabilities, where we look at probabilities after we look at data. But now we're still going to play around with a little bit of theory stuff. So there is this law thing. It's not really a law. It's a rule thing that accountants use, especially accountants that work for the government, that come around and check your accounts for a big business to make sure you're not making the numbers up. Okay? So to ensure that what your accounts that you say are really what your business is doing, they want to check receipts. They want to check they want to check your math. But there's one other kind of test they do to see if you are what is called cooking the books. And that falls under what's called Benford's Law. So Benford.
Is this recorded? No, right?
Yes. Benford, I don't know who Benford is. But he's credited with Benford's Law. And when you have numbers written down on accounting books, those numbers all start with some digit. None of them start with 0. Why does it do this? I tell it, don't show this message again. Okay, those numbers will start with either a 1, a 2, a 3, a 4, a 5, a 6, 7, 8, or 9. And then there'll be digits after that. Well, those numbers come with the proportion or the probability of starting with a 1, so like 1,762, 1,582,000. Starting with the first digit is a 1, those come at the rate of 0.301. Ladies? So that's quite a bit. That's almost 1/3 of the time, right? So your first digit being a 2 in all of your accounts come with a proportion of 0.176. With a 3 is 0.125. With a 4 is 0.097. With a 5 is 0.079. With a 6 is 0.067. With a 7 is 0.058. Starting with an 8 is 0.051. And starting with a 9 is 0.046. Hopefully you can add numbers together today as I run through some questions. And if I ask you to add some things, multiply some things, hopefully you can do that in your head or in a calculator. Yes, sir?
Wait, so what do you mean there's a 30% chance that 1 is?
So what I have is these numbers and numbers and numbers that I report my accounts to, that I make my income taxes out of. I have all these numbers of all of my income and outcome. There's a whole bunch of separate numbers here, like the amount of income that I made today from my sales was 3,586. That number starts with a 3. So starting with a 3 in all the books, if I look at all the numbers in the books, I should have about 12.5% of them start with a 3. Okay? So this, data was put together. This was investigated. Yes, sir?
So these are all just random numbers, like.
They're not just random numbers. Somebody looked at a lot of accounting books and put this together. Saw the occurrence of the leading digit being a 1. Saw the occurrence of the leading digit being a 5. all those digits, and they came up with this proportion. And now it's used by accountants to check other accountants' books. The government uses it for checking your books with your tax situation. So these aren't random proportions. These proportions were gathered from a whole bunch of data, a whole bunch of accounting books. Okay? Yeah. So once they got them, now everybody uses Benford's law. It's used. Okay. So if I'm going to investigate somebody's taxes, I might just pull one sheet from their accounting and see see what proportion the leading digit on those numbers was a 1. Okay? If it's around 30%, I'll say they're probably not making the numbers up. If it's around 10%, I'll investigate a little further. So yes, they certainly can still cheat, but this is certainly something that's used. This is why you have to go to college in order to do these kind of jobs. Okay, good. All right. So if I'm going to ask you the probability of a leading digit, GIT, to be equal to 7, so I'm going to write this, the probability of the digit being a 7. You would tell me that's 0.058, 5.8%, whichever you want to do. You can do it as a proportion or a percent. Okay? So, but then I might ask you, what's the probability, and I'm going to start to abbreviate, of the first digit, so I'm going to call that LD, to be a 7 or a 9. Okay? So in probability abbreviations, I would write that capital P, parentheses, 7 or 9. And in set notation, I write that as the probability of 7 union 9. So you'll see it written that way also. And that would be the probability of getting a 7 plus the probability of getting a 9. 7 is 0.058. Yeah, that's a U in set notation. It's called union. And 0.046. Can somebody add those up for me? 0.104. Okay. So now let's play with some things that may be a little more interesting than that. What's going to be the probability of an odd number? Okay. So my odds are 1, 3, 5, 7, and 9. So my probability of an odd is the probability of getting a 1 or a 3 or a 5 or a 7 or a 9, which is going to be 0.301.
So does that mean just like adding it?
Yes, the U means add, or means add. 0.125 plus the, and shh, guys. In set notation, you use the U. In probability notation, you use the U. 125, 079, 058, 046. Somebody add those while I get the phone. I won't be able to hear. Yes, sir. All right. Yes. I've slowed down. I'll answer a question.
I do not see a picture.
Shh. Okay. What if I wanted to find the probability of an odd number or a number greater than 6? Okay. So if I said an odd number or a number greater than 6, I could write this probability of odd or greater than 6. Or I could write this as the probability of an odd or greater than 6. And my so odd or greater than 6 would be, my odds are 1 or 3 or 5 or 7 or 9. And what other numbers do I need to add?
6.
Greater than 6.
No.
So I got to add 8. All right, and that's it. Okay? So let's see. That should become the probability of an odd number added to the probability of a number greater than 6. And sometimes you can split up your probabilities this way. Probability of an odd number is the probability of getting a 1, 3, 5, 7, or 9. Probability of a greater than 6 would be the probability of getting a 7, or an 8, or a 9. Ladies and gentlemen, stop. Thanks. But I've done something a little bit wrong here. Do I have any repeats here? Yeah. So we don't add in the probabilities of the repeats, otherwise we're going to get a probability greater than 1. So I do something real fancy, which is I find the probability of an odd, I add it to a probability of greater than 6, and I subtract out my repeats, the ones that are in both lists, the 7 and the 9. The ones that are in both lists are the ones that are both odd and greater than 6. Yes, you can cross them out at the beginning or you can cross them out now. So, but I use this example to explain one more symbol, and that is the intersect symbol, which stands for and. This one is intersect, and it stands for the word and. So I've got to leave out those duplicates, so I subtract them back out. And if I had a little more time, I'd throw some numbers in there and show us how this works. So these lines don't work, but these lines do. So that ends up being the probability of getting a 1, 3, 5, 7, or 9, plus the probability of a 7, 8, 9, subtracting out the probability of where the intersection is, subtracting out the probability of the 7 and the 9. Okay? Is that all you can stand? All right. One more. Ah, not one more. Never mind then. You'll read it in your book and you'll figure it out.